In this video, we will discuss Chapter 2 Polynomial Exercise 2.1. In this exercise, we are having 5 questions, and these all questions are based on introduction of polynomials. We already discussed about the introductions of polynomials. Once we know these concepts, then we can easily to solve these all questions. Now I am taking first question. That one is what? Which of the following expressions are polynomials in one variables and which are not? In the question number first, we are having 5 questions. In the question number 1, we are having 1, 2, 3, 4 and 5. 5 questions. We want which one is the polynomial and which one is not polynomial. Once we know the definition of the polynomial, then we can easily to identify which one is polynomial and which one is not polynomial. Just I am revising definition of the polynomials. What about the polynomials? Having many terms, but it is a algebraic expressions having constant variables like. So it is the algebraic expression in which power of variables, or we can say exponent of a variables should be what? Whole number. Power of variables, this is a one polynomial. It is the algebraic expression. Now in which power of variable, x is a variable, 4 is the coefficient of x square, minus 3 is the coefficient of x, and 7 is the constant term. Now what about the power of variable x? It is having 1 power and it is having 2 power. It means power of variables are what? Whole numbers. Whole numbers are what? 0, 1, 2, 3 and so on. So we can say this algebraic expression is a polynomial. This one is what? Polynomial. Now I am taking next one. Y square plus square root of 2. Now, what about this one? This is the polynomial or not? It is satisfying condition or not? What about the polynomial? Power of a variable should be what? Whole number. In which y is a variable and its power is 2 and it is the whole number. Root 2 is what? Constant term. We will not discuss about the constant term. We will discuss only of a power. If power of variables like x, y, z, t, p, these powers should be whole number, then we can say that one is the polynomial, otherwise not. So this variable having power 2, it is the polynomial. This one is also a polynomial. Clear? Now next one, 3 square root of t plus this one. I am writing this one there. Question number first 3-1. Question number first 3-1. And what is this question? This one is 3 square root of t plus t times of root 2. This one is a polynomial or not? Polynomials of one variable. In all questions we are having single variable. Yes or no? Not 1 to 4 we are having single variable, but in the question number 5 we are having more than one variable. So we will discuss later, but first observe this one. 3 square root of t plus t root of square root of 2. This can be written as 3t power 1 by 2 plus t times of square root of 3. Now in which t is a variable, 3 is the coefficient of this one, and square root 2 is the coefficient of t. This is the coefficient of t. This can be written like this: 3t power 1 by 2 plus square root of 2 into t. So coefficient of t is the square root of t. This variable having power 1, this variable having power 1 by 2. Is it following definition of the polynomials? No. It is a algebraic expression, that's okay, but power of a variable should be what? Whole number. Power of variable should be whole number like this 0, 1, 2, 3 and so on. But in this expression we are having power 1 by 2. So this is not a whole number. So we can say this one is not polynomial. This is not polynomial. This one is not a polynomial. So question number first, third one is not polynomial. Now next one. Fourth one. What about the fourth one? I am taking there. Question number fourth one. We'll discuss. First, fourth one is what? Question number first, fourth one. And that one is y plus 2 upon y. Now simplify this one. This can be written as y plus 2 times of y power minus 1. Now in which we are using variable y. Clear? 2 is the constant of this one, coefficient of y power minus 1. So this variable having power 1, but this variable having power minus 1. So in the expressions, all variable power should be what? Whole number. But this one is a whole number, but this one is not a whole number. So we can say this polynomial is also not expressed. This polynomial, this expression is not a polynomial. This is not polynomial. So why this one is not polynomial? Because variable power is negative. So directly we can say this one is not polynomial. So again I am revising question number. What about this question? We want to polynomial. We identify which one is the polynomial or which one is not polynomial with reason. This one is the polynomial because variables all power is what? Whole number. Non-negative integers. Also we can say non-negative integers means power should be whole number. We cannot use negative power in the polynomial. So this one is the polynomial. This one is polynomial. Okay. Why? Because its power is whole number. This one is not polynomial because this one variable is t and it is having power half, and it is half is not a whole number. This is not polynomial. Once we simplify, then we are getting y power minus 1. It means it is having one variable having negative power. So this one is not polynomial. Now fifth one. Observe this one. What we want in the question, which of the following expression are, which one of the following expressions are polynomial in one variable? We want on the basis of the variables, we are having one variable polynomial, two variable polynomial, three variable polynomial, four variable polynomial and so on. So we require which one is the one variable polynomial. First and second, both are one variable polynomial. Third and fourth, both are not polynomial. But this one is a polynomial. This one is the polynomial. Why? Because all variable power is what? Whole. So this one is the polynomial, but this is not a one variable. This is not one variable. X power 10 plus y power 3 plus 3 power 50. Not one variable polynomial. Not one variable polynomial. Polynomial. It is not one variable polynomial. This one is the polynomial, but not one variable polynomial. How many variables we are using? 3. In which we are using 3 variables. 3 variables we are using. So this is the 3 variable polynomial. How many variables we are using? 3. So this one is a 3 variable polynomial. Clear? So now I am taking next question. So this question, this one, we can identify polynomial or not once we know the definition. So what is the definition? Algebraic expressions Polynomials are what? Algebraic expression and in which power of variables should be whole number, non-negative integers. It means not negative power. So that one will be what? Polynomial. And one variable, it means we will have what? We will be having one variable. We cannot use 2 or 3. One variable means like this one. In the expressions we are having only single variable, in which x is the variable, in which y is the variable, so on, like. But this one is not a one variable polynomial, it is having 3 variables. So it is a 3 variable polynomial. Now next question. Write the coefficient of x square. What we want? Coefficient of x square we want in this question, in each of the following, in which we are having 4 questions and we want the coefficient of x square. So coefficient of x square is what? If a number in front of x square will be what? Coefficient with a sign. If positive, then no necessity to sign, but if negative numbers are in front of x square, then we will use negative sign. Clear? Now observe this one. Write the coefficient of square. This one is the x square and its front we are having plus 1. So its coefficient is what? 1. Its coefficient is 1. Now this one. Now this is the polynomial. And in the coefficient of x square, in front of this one we are having minus. No one is there, it means 1 is there. So we can say its coefficient is minus 1. Now this one. This is x square. In front of this we are having pi by 2. So its coefficient is what? Pi by 2. Its coefficient is what? Pi by 2. Now next one, in which we are having x coefficient only. We are not having x square term. So x square coefficient will be what? 0. X square coefficient will be what? 0. So what? Observe. Write the coefficient of x square. Coefficient of x square means in the front of what number we are having? X square. With a sign we will consider, in which we are having x square in front. No one is there means 1. And sign will be what? Plus 1. There no one is means what? 1. Minus 1. There pi by 2. But in which we are not having x square term. So coefficient of x square will be what? 0. Clear? Now next question. Write one example. Each of the binomial degree 35. One example we want. Binomial, monomial, binomial, trinomial. On the basis of the term, we classified polynomials in the 3 ways. Monomial having single term, binomial having 2 terms, trinomial having 3 terms. Now first we want one example of a binomial of degree 35. Binomials having 2 terms. So its result will be what? 2 terms should be in our expression. X plus 1. I am taking x as a variable. X plus 1. It is the 2 terms. One is the x, another one is the 1. 2 terms. So this one is the binomial. But with degree 35. What degree this expression having? Its degree is 1. Maximum power of x is 1. So it is not a binomial of degree 35. So convert it into the degree of 35. So we will put power of variables should be this one. I am writing again. How? Binomial of degree 35. I am having x power 35 plus 1. This is a one example. I am using x as a variable and its maximum power of variable is 35. So it's this expression having degree 35. So binomial of degree 35, binomials meaning is what? 2 terms. This expression having 2 terms and its degree is what? Maximum power of variable 35. So there is a 35. So this one is what? Degree of this expression is 35 and this one is the binomial. So this is the required what? Example. Now next one, a monomial of degree 100. What we want? Monomial. Only 1 term. Monomial means 1 term. But that expressions polynomials, degree will be what? 100. So how we will write? I am writing there y. I am taking y as a variable. Now this is the monomial, but its degree is 1, but we want 100, so we will put power 100. Now this one is the example of monomial of degree 100 is this one, and this one is what? Binomial. This is the example of binomial of degree 35. Getting? Now next question. Write the degree of each of the following polynomials. Now what about this one? Degree. Degree of a polynomial is what? Maximum power of variable. Degree is what? Maximum power of variable. Observe, without calculation we can give the response each and every question. Observe this one. Write the degree of each of the following. First one. In the first question of this one, we are having x is the variable. Now this term having variable x and its power is 1, its power is 2, its power is 3. So maximum power of variable in this polynomial we are having 3. So its degree will be what? Its degree will be 3. Its degree will be what? 3. Now next one, 4 minus y square. 4 is a constant term, y is a variable. Variable's maximum power will be degree. So its degree will be what? Its degree will be 2. Now next one, 5t minus root 7. This root 7 is the constant term. Variable is t and coefficient of t is what? 5. And its power of variable is 1. So its degree will be what? 1. So question number this one having degree 1, maximum power of a variable. Now this one 3, and 3 is the constant and constant polynomial, and constant polynomial degree will be what? 0. Constant polynomial degree will be what? 0. So what will be the degree of this constant polynomial? How it is getting? Once we multiply x to the power 0 and degree maximum power of how? 3x power 0, we can write 3x power 0 will be what? 3, and its degree is what? Maximum power of 0, and maximum power is 0, so its degree will be 0. Directly we can say constant polynomial having degree 0, so its degree will be what? 0. So in this question what we are discussing? Degree of a polynomials. Degree is what? Maximum power of a variable. Clear? These all are the linked to one variable. In your syllabus we are having what? One variable polynomial. So how we will find the one variable polynomial? Like this. But if we are having two variable polynomial, this one is having another process. But in our syllabus we are having only one variable polynomial. So one variable polynomial, maximum power of a variable will be what? Degree of that polynomial. Now last one. Classify the following as linear. Classify the following as linear, quadratic and cubic. We want to classify following polynomials. In question number 5 we are having 7 polynomials. We want which one is the linear, which one is the quadratic, and which one is what? Cubic. So we know well in a linear, I am just writing their general form of linear, quadratic and cubic. Observe. General form of linear, quadratic and cubic. What is the general form of linear polynomial, quadratic polynomial and cubic polynomial? Ax plus 1, ax square plus bx plus 1, and it is ax cube plus bx square plus cx plus d. These are what? General form of linear, quadratic and cubic. Now what we want? Which one will be linear, quadratic and cubic? We want to identify. So like this expression. And what about its degree? Linear polynomials are having degree. What about the degree? Linear polynomials are having degree 1. This one having degree 2, and this one is having degree 3. On the basis of the degree, we can identify linear, quadratic and cubic. Observe. First one, x square plus 1. Maximum power of a variable. What is the degree? This is having 1, this is 2. So maximum power is 2, and maximum power 2, it means its degree is 2. And degree is 2, then what we can say? Quadratic. What we can say? Degree is 2. Its degree equal to 2. So we can say this one is quadratic. Now next one. X minus x cube. First we want to degree. This variable having degree power 1 and this one is having 3. Maximum power is what? 3. So its degree is 3. So it is what? Cubic. Now next one, this one. Its power is 1. This variable power is 2. Degree will be 2. Maximum power of a variable, and 2 means quadratic. 2 means what? Quadratic. Now next one, this one. Variable is x, its power is 1, maximum power is 1, so we can say linear, having maximum power 1, so its degree is 1, and when degree is 1, then that is called linear. Now this one, in which t is the variable, t is a variable, its maximum power is 1, degree 1, so what we can say? Linear. Now this one, we are using what? R is a, in which r is variable and its maximum power is 2, so degree 2 and it is quadratic. Now last one, there x is the variable and its power is 3, so we can say its degree is 3, and once we are having degree 3, that is called cubic. So what about these questions? Observe, in these all questions what we are doing. In these all questions are based on the basic of the polynomials. We are identifying degree, checking polynomial or not, one variable polynomial or not. We are finding coefficient of x square. In this way we can also find coefficient of the x, and what? Another one is what? Degree, and identifying what? Linear, quadratic and cubic. Which polynomial is linear, which one is a quadratic, and which one is polynomial. So once we know the basic introduction class of this exercise, introduction of this chapter is very important to solve this exercise 1 point, not 1 point, this is the chapter 2. So this is the exercise is what? 2.1. So for getting this solution, once you revise the introduction class, then you can easily to identify how to find the degree, how to identify the coefficient, and how to do polynomials, how to identify the polynomials. So introduction of polynomial is very important class. You can revise that class and then you can try these all questions of exercise 2.1. That's all about this class. Thank you so much.